our research topic is RAG wireless access point. We are Ruth, Tyler, and Matthew. A RAG wireless access point is one installed on a network without the owner's permission, and most of the time for malicious reasons. RAG access points helps to achieve man-in-the-middle attacks by creating a false point of connection that allows an attacker to intercept and manipulate our data. How was this type of attack discovered? Well, early wireless adoption, as wireless network become more prevalent in business and homes, the potential for unauthorized access point emerged. And there's a growing security awareness as cybersecurity practice matured, professionals began to recognize the security implication of uncontrolled wireless access. And there's increased sophistication of attackers. As attackers become more skilled, they become exploiting RAF APIs for malicious purposes, which was around early 2000, leading to a greater understanding of the associated dangers. This kind of attacks have dangerous for several reasons, which includes data interception and theft, man-in-the-middle attacks, malware distributions, unauthorized access, network accesses, network disruptions, and evil twin attacks. Evil twin attacks, this is a very dangerous form of RAF AP where the attacker mimics a valid access point. Users connect thinking that they are safe on the network when in reality their data is being monitored. To demonstrate the real-world impact of RAF access point, we set up a control environment. We use the classic Linux SYS WRT54G router and flashed it with OpenWRT, a powerful open source firmware to give us the necessary control. This stimulates a RAF access point deployed within a network. The next step was to position the RAF AP network to perform a man-in-the-middle attack. We did this by figuring ARP spoofing. This technique tricks devices on the network into sending their traffic to our RAF AP. We also enabled IP forwarding, which allows the router to pass traffic between the victim and the internet. Then we used IP tables, the Linux firewall, to direct all HTTP traffic destined from port 80 to port 8080. This reroutes all unencrypted web traffic to our proxy server. Instead of using existing tools, we developed a custom Python script to handle the binary verification process. This script functions as an HTTP proxy, listening to a port 8080 for incoming requests that we redirected using IP tables. When a request comes in, the script first analyzes the HTTP request to extract the hostname of the required website. This allows the script to forward the request to a correct server. The script then establishes a connection to the server, forwarding the original request and capturing the full HTTP response. This response is what we normally be sent directly to the client. The script then checks if the request file ends with the .exe, indicating an executable file. This is a simple but effective way to identify potential binary downloads. If an executable is detected, the script opens our Trojan horse payload file and appends the entire payload to the end of the HTTP response. This modifies the download file into changing its apparent file type. Finally, the modified response now contains the Trojan payload is sent back to the client. From the client perspective, this appears to be a normal file downloaded. However, when executed, the Trojan horse will also run, establishing a connection to our attacker machine. This is our demonstration.
For our practical demonstration, we set up a desktop PC that is wirelessly connected to our Linksys 3200 WRT, which is currently running OpenWRT here. And there's a wired connection between this laptop and Linksys router, which is hosting a very simple Python file server on HTTP over port 80. And what we will be doing is connecting via the desktop through the router to the file server to download a simple executable. To demonstrate that executable real quick, we have not a trojan.exe. And if we run that, we'll see we get this executable was legitimate. However, when we go to the IP address of that Python server, we see that it's not loading. And this is because on the router, we have an IP table that will take any outbound traffic on port 80 and redirect it to itself at port 80. What needs to happen is we need to have this Python script running, which will take any traffic redirected to it and act as a proxy, sending out the traffic from the server and then taking data back in. And what that data will do, or what that script will do, is analyze that data and determine if it's an executable. If it is an executable, it will prepend it with a fake Trojan that we designed for demonstration purposes. Otherwise, it just passes the data back to the original requester unchanged. So if we run this script, we'll see it's starting to work. And we go back to the web browser. We refresh, ensuring that we are connecting on HTTP, and we give it a second. We see that we are able to see the directory that the Python file server is hosting. And now we can download this notatrojan.exe, and we give it a second because I'm sure something else has been caught and isn't communicating properly. And now we can open the downloads page, and I already set up the command prompt here to be on the downloads page. So if we run this notatrojan.exe, we get spooky Trojan horse, showing that the file is altered. And the way that we have this set up to run is with this Python code here. It will open a socket server, receive requests that are sent to it over port 80, and then send them out and wait for responses using this receive function, check if they are EXEs, and if so, prepend the data in the necessary spot to allow it to be executable on another system. And then finally returns it to the original sender.
How can we defend against this kind of attack? We have to have wireless intrusion detection and prevention systems. These systems continuously monitor the wireless network from unauthorized access point, suspicious activity, and policy violation. They can automatically block or contain WAF APs. Regular wireless network audits. Conducting regular audits help identify vulnerability in unauthorized devices. This includes physical inspection of network infrastructures, strong encryptions like WPA3, use of this strongest availability encryption protocols to protect wireless communications. We can have physical security measures. We can have WAF AP detection tools or centralized wireless network management. So the lesson we learned today is to trust no network. Users should be wary of connecting to unknown or unsecured Wi-Fi networks. Even seamlessly legitimate networks can be compromised. Physical security matters. We should understand that. Network visibility is crucial. Organization must be comprehensive visibility into their network traffic to detect unauthorized devices and suspicious activities. Employees' education is vital. Employees need to be educated about the risk of WAF APS and the importance of adhering the security policies. And wireless security is more than just a password. While having a strong password for your wireless network is a good start, it does not prevent a WAF access point from being installed on your network. Do you have any questions? You can write it on the comment section. And thank you for listening to us.